Die casting is an incredible process. It allows us to create metal parts with amazing detail. These parts are everywhere. Cars, electronics, and even toys are made using this process. The secret lies in the molds. These special molds, called die casting dies, are the unsung heroes of the manufacturing world. Die casting dies are like cookie cutters for metal. Molten metal is injected into these dies under high pressure. This creates complex shapes with incredible precision. The dies themselves are meticulously crafted. They're made from very tough materials that can withstand extreme temperatures and pressure. These dies are essential to mass production. They allow manufacturers to make thousands, even millions of identical parts. Without them, many of the products we rely on would be far more expensive or even impossible to make. The process of making these dies is a fascinating journey of engineering and precision. Let's take a closer look at the steps involved in creating these manufacturing marvels. From design to testing, each stage plays a crucial role in shaping the future of manufacturing. Before a single spark flies in the factory, the die-casting die begins its life as a digital blueprint. Skilled engineers use advanced computer-aided design, or CAD software, to create these detailed designs. They carefully consider the final part's shape, size, and function. These digital designs are more than just pretty pictures. They are complex three-dimensional models. Engineers use these models to simulate the die casting process virtually. This helps them identify and correct any potential problems early on. Simulations ensure that the molten metal will flow correctly within the die. This prevents defects and ensures a high-quality final product. The design phase is critical. It lays the foundation for the entire die-making process. It ensures that the final die can produce parts that meet the required specifications. With the digital blueprint finalized, the journey moves from the virtual world to the factory floor. The digital design is transformed into a physical reality through a process called machining. Large blocks of hardened steel are used as the starting point for the dies. These blocks are incredibly tough and can withstand the high temperatures and pressures of die casting. Computer numerical control, or CNC machines, are the workhorses of this transformation. These sophisticated machines use the digital design as a guide. They carve away at the steel block with incredible precision. Specialized cutting tools shape the intricate cavities, cores, and runners that make up the die. The machining process is slow and meticulous. It can take days or even weeks to complete, depending on the die's complexity. The goal is to create a mirror image of the desired part within the steel blocks. This ensures that when molten metal is injected, it takes on the intended shape with accuracy. The heat is on, strengthening dies for production. After machining, the die-casting dies undergo a crucial process called heat treatment. This process is like giving the dies a suit of armor. It makes them incredibly strong and resistant to wear and tear. Heat treatment involves carefully heating the dies to very high temperatures. This is followed by a controlled cooling process. This precise heating and cooling cycle alters the microstructure of the steel. It makes the dies incredibly hard and durable. Heat treatment is essential for extending the lifespan of the dies. It ensures that they can withstand the extreme conditions of repeated die casting cycles. Without proper heat treatment, the dies would quickly wear down. This would lead to imperfections in the finished parts. A polished performance, refining the die's surface. With the dies hardened and ready for action, the next stage focuses on achieving a flawless finish. The surface of the dies is meticulously polished to a mirror-like sheen. This seemingly small detail has a huge impact on the quality of the final parts. Polishing removes any imperfections or rough edges left behind from the machining process. This ensures that the molten metal flows smoothly within the die. It prevents any imperfections from transferring onto the surface of the finished parts. In addition to polishing, this stage also involves the assembly of various components. Cooling channels are integrated into the die. These channels circulate coolant during the die casting process. This prevents the die from overheating and ensures consistent part quality. Trial by fire, testing and perfecting the die. The die casting die is now ready for its final test. It is mounted onto a die casting machine and prepared for a trial run. Molten metal is injected into the die under high pressure. The results are carefully examined for any defects. This initial test run is crucial for identifying any imperfections. The die may undergo minor adjustments or refinements to ensure optimal performance. Once the die consistently produces high-quality parts, it is ready for mass production. The die-casting die, having passed its rigorous testing, is ready to play its part in shaping the modern world. It will produce thousands, even millions of identical parts. These parts will find their way into countless products that we use every day. Conclusion: the enduring impact of die casting. The journey of creating a die casting die is a testament to human ingenuity and precision engineering. From the initial digital design to the final polishing touches, each step is crucial in creating a tool capable of producing high-quality metal parts with incredible accuracy. Die casting dies are the unsung heroes of modern manufacturing. They play a vital role in shaping the world around us. Understanding the process behind their creation provides a deeper appreciation for the complexity and precision hidden within the everyday objects we often take for granted.